Hello friends, welcome to my lecture on validity of arguments. Let us first define what is an argument. An argument is a process which yield a conclusion, that is another proposition from a given set of propositions called premises. Okay. So, let premises, that is a given set of propositions, be P1, P2, P3, Pn. Okay. An argument yield the conclusion, that is another proposition which we can denote by Q. Okay. Then such an argument is denoted by P1, P2, P3, Pn gives Q, conclusion Q. Okay. Now, valid argument, when we will call the argument to be valid. So, argument P1, P2, P3, Pn gives Q is called valid if Q is true whenever all its premises P1, P2, P3 are true. An argument is called valid if and only if the premises implies the conclusion. Thus, the argument P1, P2, P3, Pn gives Q is called valid if and only if the statement P1 and P2 and so on and Pn implies Q is a tautology. Okay. That is, when you form the truth table of P1 and P2 and so on and Pn implies Q, okay, the last column should be having all truth values T. So, we will call the argument A1 argument P1, P2, P3, Pn gives Q to be a valid argument if P1 and P2 and so on Pn implies Q is a tautology. If it is not a tautology, we will call it a invalid argument. Okay. So, argument which is not valid is said to be a fallacy or an invalid argument. Representation of an argument. Argument P1, P2, P3, Pn implies Q is written as P1, P2, Pn, these are premises, and then we write a horizontal line and Q, this is conclusion. So, we write premises P1, P2, Pn, okay, and the conclusion above the conclusion we write this horizontal line. Okay. So, this is how we denote the argument P1, P2, P3, Pn implies gives Q as where Q is the conclusion. Now, let us test for validity of an argument. When we want to test the validity of an argument, symbolize each premise. Okay. Each premise is to be symbolized and the conclusion also has to be symbolized. Then we will make a truth table that has a column for each premise. Okay. Suppose there the premises are n, okay, P1, P2, P3, Pn. So, there will be n columns, one column for each premise and a column for the conclusion. Okay. Now, if you denote the conclusion by the proposition Q, then there will be a column for Q. Now, if the truth table has a row where the conclusion column is false. Okay. So, if there is a row in the truth table where the conclusion column is false while every premise column is true, okay, while every premise column is true, then the argument is invalid, otherwise the argument is valid. Okay. Now, let us look at law of syllogism. So, since the statement P implies Q and Q implies R implies P implies R is a tautology, we can see that let us say let us form the truth table P Q R T T T, okay, T T F T F T T F F, okay, then F T T, then F T F, then F F T, then F F F. Okay. So, there will be 8 possibilities 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, let us write the column corresponding to the truth values of P implies Q. Okay. So, T T gives T, okay, T T gives T, then T F gives F, okay, T F gives F, then F T gives T, then F T gives T, then F F gives T, then F F gives T, okay, and Q implies R. Let us write for Q implies R. Okay. So, T T gives T, T Tf gives F, okay, Ft gives T, Ff gives T, Tt gives T, Tf gives F, okay, Ft gives T, and then Ff gives T. Then P implies Q and Q implies R. Let us write for Q implies R, okay, P implies Q and Q implies R. So, T and T, T and F, F and T, F and T, F, Tt is T, Tf is F, Tt is T, Tt is T. Okay. Then P implies Q, okay, P implies Q and Q implies R, okay, implies P implies R. So, we have to write the column for P implies R also. Okay. So, let us write here P implies R, okay. P implies R, Tt is T, okay, Tf is F, then we have Tt is T, then we have Tf is F, and then we have Ft is T, then we have Ff which is T, and then we have Ft which is T, and then we have Ff which is T. Okay. Now, let us write this column corresponding to P implies Q and Q implies R implies P implies R. Okay. So, we have P implies Q and Q implies R, T here. Okay. So, and this implies this, okay, this implies this. So, T gives T, okay, then F gives T, then F T gives T, okay, then F gives T, then T gives T, then F T gives T, and then T gives T, and then T gives T. Okay. So, if you look at this truth table, then P implies Q and Q implies R implies P implies R is a tautology. You can see it is a tautology, and therefore, it is a valid argument. Okay. So, P implies Q is a premise, Q implies R is a premise, okay, and the conclusion is P implies R. Okay. This is known as law of syllogism. Now, let us go to rule of detachment. P and P implies Q is a tautology. We can see that P, Q, P and Q. P implies Q. Let us first say P implies Q, then we write P and P implies Q. Okay. And then we write the column for P and P implies Q implies Q. Okay. So, this is T, T, F, T, F, F. Then P implies Q, Tt gives T, Tf gives F, Ft gives T, Ff gives T. Then P and P implies Q. Okay. So, Tt gives T, Tf gives F, Ft gives F, Ff gives F. Okay. Now, we have taken P and P implies Q. Okay. Now, P and P implies Q implies Q. Okay. So, we have to write the truth values of this proposition. So, T gives T, okay. Then F gives T, okay. Then Ft gives T, then Ff gives T. Okay. So, all the entries in this column, okay, they are T. Okay. Therefore, P and P implies Q is a tautology. Okay. And so, P and P implies Q, if they are premises, they give the conclusion Q. Okay. Q is a conclusion. This is called rule of detachment. Now, we will use this rule of detachment in this example. You can see we have P implies Q implies R, and these are the premises. Okay. The premises are P implies Q and Q implies R. these are the premises. The conclusion is R. R is the conclusion. So, let us prove this. Okay, let us show this by using the law of detachment. Okay. So, P and P implies Q. Okay. Let us take these two premises. So, by law of detachment, P and P implies Q gives Q. Okay. The conclusion Q. Now, let us take Q and Q implies R. Okay. Q and Q implies R. So, by rule of detachment again this gives you R. Okay. So, here these are premises, this conclusion. Then we take this Q and combine Q with Q and R. So, now these become premises. So, P and P implies Q, the two premises give us conclusion Q, then Q and the premise Q and the premise Q implies R gives us the conclusion R. So, without using the truth table we can show that in this case R will be the conclusion. We can do it by truth table also. So, P Q R, okay, T T T, then we have T T F, then we have T F T, then we have T F F, then we have F T T, then we have F T F, and then we have F F T, and then we have last case F F F. Okay, F F F. This is the last case. So, we have 8 possibilities, T 4 5 6 7 8. Okay, and we can then find the truth value of P implies Q and then truth value of Q implies R. Okay, Q implies R. So, P, then P and P implies Q and Q implies R we can find. Okay, and then we will find P and P implies Q. So, that we can write here, P and P implies Q and Q implies R goes to implies R. Okay, the truth value for this. So, P and P implies Q. So, T T gives T, okay, T T gives T, then T F gives F, okay, T F gives F, then we have F T gives T, then we have F T gives T, then we have F F gives T, then we have F F gives T. Okay. Then Q implies R, T T gives T, T F gives F, okay, F T gives T, then we have F F gives T, then we have T T gives T, then we have T F gives F, and then we have F T gives T, and then we have F F gives T. Okay. Then P and P implies Q and Q implies R. Okay. So, we have to consider, let us first consider P and P implies Q. Okay. So, we have to do it in steps. So, now let us write the truth values of P and P implies Q. Okay. So, P and P implies Q. So, P has truth value T, P implies Q has truth value T. So, we have T here, then P has truth value T, P implies Q has truth value T. So, we have T here, then this is T, this is F. So, we get F. Okay. This is T, this is F. So, again we get F. Okay. Then here we have F, here we have T. So, we get F, here we have F, here we have T. So, we get again F, then here F, here T. So, again F, and then here F, here T. So, again F. Okay. Now, P and P implies Q and Q implies R. Okay. So, let us combine, let us consider this column, this column. Okay. So, T T, okay, is T, T F is F, okay, F T is F, then we have F T, again F, then we have F T. So, we have F here, F F is F, then we have F T F, and then we have FTF. Okay. Now, P and P implies Q and Q implies R, implies R. Okay. So, this column we have to consider and this column we have to consider. So, T T gives T, okay. F F gives T, then F T gives T, okay. Then F F gives T, then we have F here, we have F here, okay, F here and T here, okay. So, again T, okay. Then we have F here and T here, so again T, okay. And then we have F here and here also F. So, we have T here. So, all the values 1, 2, 3, 4, 5, 6, 7, one more value is left out, T T gives T, F F gives T, F T gives T, okay. Then F F gives T, okay. Then we have F T gives T, okay. And then we have F F gives T, then F T gives T, and then F F gives T. So, one more T is there, okay. So, all entries in this column are T, and therefore, P and P implies Q and Q implies R. Q implies R is a tautology. Okay. So, this argument is valid, okay. This argument is valid. So, this is another way of proving that the argument P implies Q, Q implies R gives R is valid. Okay. Now, let us test the validity of the following argument. If a man is bachelor, he is buried. So, let P denote a man is bachelor. And Q denote he is buried. Then this premise can be symbolically written as P implies Q. Now, second one, if a man is buried, okay, he dies young. So, let R denote he dies young. He dies young. Then the second premise can be written as Q implies R. Okay. So, we have to test the validity of this argument. If a man is bachelor, he is buried, that is premise. If a man is buried, he dies young. The conclusion is bachelors die young. So, let us say P implies Q, Q implies R. Okay. These are premises. Okay. Then the conclusion is R, bachelors die young. Okay. So, let us see P implies Q. So, this is P implies R. Okay. So, we can show that the conclusion is P implies R, that is bachelors die young. So, we have P implies Q and Q implies R. Okay. The conclusion is P implies R. Okay. So, let us make the table for this P Q R. Okay. So, T T T T T F T F T T F F, okay, T F F, and then F T T F T F F F T, then F F F. Okay. So, 1 2 3 4 5 6 7 8. Okay. Now, P implies Q. P implies Q is T T gives T, T T gives T, T F gives F, okay, T F gives F, F T gives T, F T gives T, F T gives T, F F gives T, and F F gives T, and then we have Q implies R. Okay. So, T T gives T, T F gives F, okay, F T gives T, then FF gives T, then TT gives T, TF gives F, then we have FT gives T, then we have FF gives T. Okay. Now, P implies Q and Q implies R. Let us write truth table for this. So, truth values. So, P implies Q and Q implies R. So, TT gives T, TF gives F, okay, FT gives F, FT gives F, TT gives T, TF gives F, and TT gives T, and then TT gives T. Okay. Now, we write the truth values of P implies R. So, P implies R, TT gives T, then we have TF gives F, then we have TT gives T, then we have TF gives F, then we have FT gives T, okay, FT gives T, FF gives T, and then we have FT gives T, and then we have FF gives T. So, these are 8 values 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, let us write the column for P implies Q and Q implies, this is AND. Okay. So, P implies Q and Q implies R implies P implies R. Okay. So, T T gives T, then F F gives T, then F T gives T, then F F gives T, then T T gives T, okay, then T T gives T, okay, F T gives T. So, the F T gives T, then T T gives T, and T T gives T. So, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, you can see all the values are T here, truth values, and therefore, there is a tautology. Okay. So, P implies Q and Q implies R implies P implies R is a tautology. So, the conclusion is bachelors die young. Now, let us take another example. If two sides of a triangle are equal, then the opposite angles are equal. Two sides of a triangle are not equal, the conclusion is the opposite angles are not equal. So, let us say let P denote two sides of a triangle are equal. Two sides of a triangle are equal, and then Q denote the proposition the opposite angles are equal. Okay. And then two sides of a triangle are not equal. So, two sides, so not P, okay, is two sides of a triangle are not equal. Okay. So, we have P and Q, P implies Q, okay. First premise can be symbolically written as P implies Q, okay, if P then Q, and the second premise is not P. Okay. So, our conclusion is the opposite angles are not equal. Let us see the validity of the argument. Okay. So, P implies Q and not P. Okay. If it is a valid argument, okay, the opposite angles are not equal. Opposite angles are not equal. So, that means not Q. Okay. This should imply not Q. Okay. If it is a tautology, then we shall say that the argument is valid. If it is not a tautology, we shall say that the argument is not valid. So, let us write the truth values P Q, P implies Q, not P, okay, P implies Q, and not P, then not Q, and then last column will be P implies Q and not P implies not Q. Okay. So, we have T here, T here, T here, F here, F here, T here, and then F, F. Okay. P implies Q. T T will give T, T F will give F, F T will give T, F F will give T. Okay. Then not P will be negation of the truth values of P. So, F, here F, okay, here T, and here T. Okay. Then P implies Q and not P, P implies Q and not P we have to consider. So, T and F gives F, okay. F and F gives F, T and T gives T, T and T gives T. Okay. Then not Q. So, T gives F, F gives T, and then T gives F and F gives T. Okay. Then P implies Q and not P implies not Q. So, we have to consider this column and this column. So, F F gives T, okay. F F gives T, F T, F T gives T, then T F, T F gives F, okay. T F gives F, T T gives T. Okay. So, we can see here that all the entries in this column are not T. Okay. There is one entry which is F. Okay. Therefore, this argument is not valid, because this argument will be valid only when P implies Q and not P implies not Q is a tautology. So, the argument is not valid. The argument is not valid. Now, let us go to this example. Test the validity of the argument. If 8 is even, let us say P denotes 8 is even, and Q denote 2 divides and 9. R denotes 7 is prime. Okay. So, P denotes 8 is even, Q denotes 2 divides 9, R denotes 7 is prime. Okay. Then we have to see the validity of this argument. Okay. So, the first premise is if P is even, okay, if 8 is even, then 2 does not divide. So, P implies not Q. Okay. This can be symbolically written as P implies not Q. Now, 7 is not prime, R 2 divides 9. Okay. 7 is not prime, either 7 is not prime. So, either negation of Q. So, second one is negation of Q, okay, or 2 divides 9. 2 divides 9 means no, negation of R. 7 is not prime. So, negation of R or 2 divides 9. So, Q. Okay. So, second one can be written negation of R or Q, and 7 is prime, therefore, 8 is odd. Okay. So, P implies not Q and Q minus R minus negation of R or Q. We have the third premise is 7 is prime. Okay. 7 is prime. So, R, okay, this 7 is prime, 7 is prime. Then the negation, then we have the conclusion 8 is odd. So, negation of P. Okay. So, we have P, the premises are 3 premises are there. P implies not Q, then not R or Q and R. Okay. So, when these 3 premises lead us to negation of P, we have to see whether this argument is valid. Okay. So, we have P, Q, R. Okay. So, T, 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 F, T, F, T, T, F F F T T F T F F F T F F F. Okay. Then not Q. So, not Q will be F F T T then F then F then T then T. Okay. Now, P implies not Q. So, P implies not Q. So, T F gives F. Okay. T F gives F. Then T T gives T. Then T T gives T. Then F F gives T. Then F F gives T. Then F T gives T. And then F T gives T. Okay. So, we got P implies not Q. Then not R or Q. So, let us write not R. Not R is F T F T F T F T. Okay. And not R or Q. Okay. So, not R or R Q. So, F T gives F T. F T gives T, T T gives T, then F F gives F, then T F gives T, then F T gives T, then T T gives T, then F F gives F, T F gives T. Okay. Not R or Q, and then R. Okay. So, R is there already. So, we have now to consider P implies not Q or not R or Q and R. So, let us see we have to consider first the combination of the two only. So, let us see we have to consider only this. Okay. So, we have to consider P implies not Q this column and not R or Q this column. Okay. So, F and T. So, that is F. Okay. Then F T is F. Then T F is F. Then T T is T. Then T T is T. Then T F is F. Then T T is T. Okay. Now, let us combine it with R. So, P implies not Q and not R and Q or not R or Q and R. Okay. So, R is this column. So, T F is F. Okay. Then F F is F. Then T F is F. Then T T is T. Then F T is F. Then T F is F. Then T T is T. There are 6 only. So, let us see, this is I think we have missed one. Just a moment. See P this we are considering this column 1, 2, 3, 4, 5, 6, 7. There are 6 here only, 7 here. P implies not Q and not R and Q. So, we have to consider this and this column. So, we have here F T gives F. Okay. And then F T gives F. Then T F gives F. Then T T gives T. Okay. Then T T gives T. Then T gives T, T F gives F, T T gives T. So, one is missing, F T gives F. Okay. So, we have taken this, F T gives f, then T f gives f, then we have T T gives T, then we have T T gives T, then we have T T gives T, then we have T f gives f, and then we have T T gives T. So, we have written f f f 1 2 3, 3 f 3 T, 3 T, okay, 1 T is missing here. So, let us write this 3 f, okay, and 3 T, and we write 2 f. Okay. So, let us combine this with R. Okay. So, f T is f, then f f is f, then we have T f is f, then we have f T is f, f T is f. So, this is f. Okay. Now, we have T T, T T is T. Okay. So, we have here this T, okay, this T and this T, okay, is T here, and then f here and T here. So, we get f, and then we get T here and f here. So, we get f here, and then f here and f here. So, we get f here. Okay. So, these are 8 entries, 1 2 3 4 5 6 7 8. Okay. So, we have got this P implies not Q and not R and R Q and R. Okay. Now, we have to consider the last column. So, P implies not Q and not R, R Q and R implies not P. We have to write the entries in this column. So, we have to consider this column and not P column, not P column, not P we have not written. Okay. So, not P we can write here, not P will be F, 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 T, 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 T. Okay. Now, let us see implication. So, F, F gives T, okay. Then F, F gives T, then F, F gives T, then F, F gives T, okay. Then T, T gives T, then F, T gives T, then F, T gives T, and then F, T gives T. Okay. So, all the entries in this column are T, and therefore, this is a valid argument. Okay. So, 8 is odd, this is a valid argument, therefore, 8 is odd. So, with this I would like to end my lecture. Thank you very much for your attention.